Hi, so let's now have an example regarding the trigonometric substitution. See, we need to evaluate the x squared multiplied by square root of e squared minus x squared dx, wherein our a here is constant. Okay, so see, we have here, then let's go back on our facts last time, that if we have a squared minus some function that is also squared, then we will let this variable is equal to a sine theta. So we will use this one, and we will let the trigonometric substitution, which is u is equal to a, the constant, and then sine theta, right? And then our technique is we will express all our integrands in terms of theta. Okay, so all our variable x's here will be converted into theta. So based from our given integrand and using our trigonometric substitution, we will use that our variable x is equal to our constant, which is also a, then sine theta. Okay, so we have x, and then based from our equation, we need the x squared. So we will square this both sides to get the x squared, right? Okay, so we have x squared is equal to a squared sine squared theta, right? Then what else do we need? So we need an dx, a dx. Okay, so we need dx, so we need to integrate, differentiate this. So the derivative of x is dx, and then the derivative of this is, we have a, then derivative of sine is cosine theta d theta, right? So what else we need? So we have this, we have this, we have x squared. Then based from our main integrand, we need a squared minus x squared. So let's multiply this whole term by -1. So we have negative x squared, negative a squared sine squared theta, right? Because if we multiply this by -1, then it must be in both sides in order for us to retain the original equation. Okay, then what else do we need? We need to add a squared. So if we will add a squared here, we also need to add a squared on the other side to make our equation equal. So we add a squared, so we need to add a squared here also. And from here, can now simplify this. We have a squared, so we have left with 1 here, and then minus the sine squared theta, right? Then in order for us to simplify this, we will use the trigonometric identity, which is the sine square theta plus cosine square theta is just 1, diba? So the sine square theta minus 1 is equal to cosine squared theta is just 1 minus sine squared theta, right? So simply means that our 1 minus sine squared theta here is just equal to cosine e squared cosine squared theta, right? Then let's copy this. So we have a squared minus x squared, but we need the square root sign. So let's raise this by 1/2 both sides. So we have a squared minus x squared 1/2 is equal to, if we raise this both sides by 1/2, then we will have a cosine theta, right? A cosine theta, or the square root of a squared minus x squared is just equal to a cosine theta. Okay. So yan. So let's go back on our equation. So we have integral of x squared square root of a squared minus x squared dx. So our need to express in terms of theta. So we have our x squared is just equal to a squared sine squared theta, and then our square root of a squared minus x is this one. So we have multiply this by a cosine theta, and then our lastly our dx is this one. So we have multiply by a cosine theta d theta. Okay. So simply we have a squared multiplied by a, so we have a to the 4. Since this is constant, let us write this outside our integral sign, and then we're left with sine squared theta, and cosine times cosine is cosine squared theta, and then our d theta. Okay. So after that, can now further simplify this to the 4th. So we have the fact that can rewrite this as cosine theta squared d theta, right? But to remember from our product and sum formula that sine angle a cosine beta angle is equal to 1/2 times the 1/2 times the sine by its angle A plus angle beta plus sine A minus B. Right, so that is our equation for the product to sum formula, or yes, but our A here is in terms of theta, so they are both in terms of theta. So what we have left here is 1/2 sine theta plus theta, and then plus sine theta minus theta. So theta minus theta is just 0, so we have sine 0. Then we have 1/2 sine 2 theta. Theta plus theta is 2 theta. Then since we know the fact that sine theta cosine theta is equal to 1/2 sine theta, then we can replace this one with 1/2 sine 2 theta. So we have a to the 4 integral of 1/2 sine 2 theta, but it is raised to 2 d theta. So let's further simplify this by raising both constant and sine 2 theta to 2. So we have 1/2 raised to 2 is 1/2 times 1/2 is 1/4. So we have 1/4. Then we have sine squared 2 theta, right? Okay. So we can simplify this by placing the constant outside. A to the 4 over 4 integral of sine squared 2 theta d theta. Okay. Okay. Okay, so how can we further simplify this one? Since we have remember that sine square to theta is the same as a 1/2 times 1 minus cosine for theta, right? So from our trigonometry again. Okay. Okay, so this from this we can now substitute the value of our sine squared to theta, which is equal to 1/2 times 1 minus cosine for theta. Okay, so we have a to the 4 all over 4 integral of our sine squared to theta is equal to 1/2 times 1 minus cosine for theta. Okay, then our d theta. Okay, then let's also move back the constant value outside. So we have a to the 4 all over 8, then multiply by the integral of 1 d theta or d theta minus the integral of cosine for theta d theta. Okay, so from here we can now easily integrate these two integrands here. So we have a to the 4 8 multiply by the integral of d theta is just theta minus integral of cosine for theta d theta is sine 4 theta all over 4, right? This if you still cannot do it mentally, then you can now have a separate solution for this. So you have cosine 4 theta d theta. In our technique, it's just we let this 4 theta is equal to u. Then derivative of u is just 4 d theta, wherein we only need d theta, so we need to divide both sides by 4. So our integrand can be written as cosine u, then our d theta is d over 4, right? Wherein our integral of cosine is sine and our u is 4 theta, then all over 4 plus c. So we have here sine 4 theta all over 4, then our plus c. Okay, but we need to bring back or move back the value